simplifying square roots and cube roots. So we know what a square root is. It means the square root of 9 means what's the number that you would multiply times itself to get 9, right? That's literally what it means. And you say that would be 3, okay? And that is because, that is 3. That is because 3 times 3 equals 9, right? What about this? Negative 3 times negative 3, what does that equal? It also equals positive 9. So would it be fair to say that the square root of 9 is negative 3? Yeah. I mean, it can be. We don't get really deep into this in this class. But when you're given a square root, like somebody just says, here's the square root of 9, that means the positive square root. It does not, it's not asking you to show both the plus and the minus when they're just presented with a square root. When we get into solving equations and we have to take the square root, then you've got to put the plus and the minus. Okay, so we don't need the negative 3 times negative 3 at this point. Okay, what does it mean to be a cube root? Right?
Number that times by itself 3 times.
3 times to get whatever's inside, right? So, you know, what number you raise, you know, multiply times itself 3 times equals 8? 2 times 2 times 2. Now, when you do these cube roots, especially on the cube roots, I mean, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, right? 4 times 4 times 4 is 64. The numbers get big pretty quickly. And since mostly what we're doing in here is kind of simplifying to nice whole numbers or something like that, you know, actually most of the answers are going to be 2 or 3 or 4 or maybe 5. You know, there's some combinations. It could be a fraction, you know, where the answer is 2/3. But I mean, most of the time, in order to keep the numbers small and, you know, that the calculation part of it is not the hard part, there's not just that many options. So that would be a 2. Again, that means that 2 times 2 times 2 equals 8. Okay, would it be true to say then that negative 2 times negative 2 times negative 2 equals 8?
No.
What would it be? Yeah, actually, because it's an odd number of negatives, that's actually not true. So there's no confusion. Like a cube root, is it plus or minus? No, it's not plus or minus. It's only the plus. If you want to take the cube root of negative 8, then you get negative 2. So it's clean. No ambiguity like there is with square roots. So our first objective, we need to learn how to simplify square and cube roots without turning them into decimals. And, John, are you okay? Okay. And then we're going to learn how to simplify square roots and numbers that are perfect squares and cube roots of numbers that are perfect cubes. Okay. So, I mean, the whole point of this is not to just put them in your calculator and do that, to kind of have some recognition of what these things are. Now, how many would say you're really good with your multiplication tables? How many would say kind of so? I don't want to like be in the multiplication table Olympics or anything, but I mean, if you know your multiplication tables up to a certain point, let's say 12 times 12, then the perfect squares are just some kind of subset of that, right? So, I mean, maybe you've got most of these memorized, but maybe not the last few. Like 11 times 11, 12 times 12, wouldn't be surprised if those are not. But the rest of them should come pretty much, you know, as quickly as you would know your multiplication tables, which you should know. You should know your perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, right? We good? Okay. So now, if you don't remember those really well, you should know that you could make a list of the perfect squares anytime you want, right? You go to your calculator, go to the y equals button, and after that put x squared, right? And then when you go to the table, which is second graph, there's table, you're going to see all the perfect squares. So, I mean, if you're suspicious that something is a perfect square, you know, just look through the table of values. If it's in the list, it's a perfect square. So you could use that to, like, if you say, what is 4 squared? 16. But you could also go backwards. You could say, what is the square root of 25? 5, right? What's the square root of 36? 6. So you could do that with a table of values, which you could easily make in your calculator. Now, perfect cubes, probably not as familiar with them as we are with the perfect squares. Okay. What is 1 cubed? 1 times 1 times 1 is, what is 1 to the 99th? 1 to any power is 1, right? 2 to the third we already said was 8. 3 to the third is 27. 4 to the third, yeah, you may get a little weak on these, but that's okay. 125. And what's 10 to the third? 1,000, right? So who knows 6 to the third? Just knows, doesn't. I mean, no, you can put it in a calculator. 216. 216. You're thinking of 14 squared. How about 7 to the third? 343. Okay. So again, if you don't know the perfect cubes, you could always just make a list of the perfect cubes, so you could check them out. A lot of times, understanding that a number is a perfect cube might be a clue to how you're supposed to approach the problem. So in this case, here's my x to the third. Here's my table of values: 1, 8, 27, 64, 125. There's the 6 to the third. I could scroll down farther than that. Actually, this is just a screenshot, so I can't. But again, if I say, what's the cubed root of 27? There's the 27, so the cubed root is 3. Right? So you could use this either direction, right? 5 squared is 125. 5 to the third is 125. The cubed root of 216 is 6. You should say, cube is just another way of saying third power, right? Cubed root is another way of saying the third root. We don't usually say that. We definitely say cubed root. Okay, so now we can do these kinds of problems, right? 3 squared is, the square root of 36 is, 9 squared is 81. The square root of 121 is, 13 squared is, right? Look in the table of values there. 13 squared is 169. Right? Okay. Is that good? About cube roots. 2 to the third is, the cube root of 125 is, 7 to the third is, look at right there, 7 to the third is 343. And the cube root of 729 is, looks like there's 729, so the cube root is 9. So the other thing is, you could actually, if you're doing some mixture, and what I'm going to give you right now is a worksheet that's got all this stuff, just square roots and cube roots and squares and cubes all on the same page. You could actually make tables of values for both at the same time, right? Put x squared on y1, put x to the third on y2, and when you go over to your table of values, these are all the x squared. These are all the x to the third, right? So just use that. And that's it. So I'm going to give you I think it says 2 worksheets. It's actually one 2-sided worksheet. Okay, stop.